Welcome to Mind Bang.
Bang. We just got a letter. I wonder who it's from. Hey Emily, have a look at this. It's got a paw print.
Dear Emily and Nicole, in physics class they were talking about work and energy, but how does energy relate to work? From Bailey.
Well, Bailey, I'm really sorry, but I don't actually know, so I can't help you this time.
Well, I guess I'll just have to teach both of you. So, the definition of work is when an object moves a distance caused by a force. Yeah. So, to show you an example of work, let's have a rock throwing competition, okay? Ready? This is my rock.
And this is my rock.
My rock is very big and heavy.
My rock is even bigger and even heavier.
Right. Okay, so Nicole's gonna throw first. So hers moved from here to here. Now it's my turn.
You know, one time I threw a rock at someone's face.
Okay, my turn. Ugh. Okay, my rock went from here
I win.
to here. Now,
My rock was bigger,
who
and I moved it further.
whose rock do you think used the most work? No, it was not Nicole's. It was mine. This is because mine has a bigger weight. Hers is smaller, and what I'm saying actually makes sense.
I'm tired.
You should go sleep. Anyway, so my rock was bigger and it went a smaller distance, but because it was a lot bigger than Nicole's rock, it still used more work. Yeah, there you go. There you go. No, Nicole, don't smash the phone! So, as you saw before, when Nicole was jumping up and down on the trampoline, when she was up high, what type of energy did she have?
Sound energy.
Not really the main type of energy you had.
Gravitational potential energy.
Whoa, how did you do that? And why did you have gravitational potential energy?
Because when I was in air, I had the potential to fall.
That is correct. So, what kind of energy did you have when you were falling down back to the trampoline?
Heat energy? Because I'm pretty hot.
No. What was the main energy you had? Kinetic energy.
Connecticut energy?
Kinetic.
Connecticut.
Yes.
That place in America. Connecticut.
So what is kinetic energy?
Connecticut energy is the energy that a moving object possesses.
When it is.
Moving
Yes.
through whatever.
Could be moving through anything.
That's why I said whatever.
So yeah. That's it for today on Mind Bang. It was funny, I was gonna say brain pop.
Well, we'll see you next time on Brain Poo.
No, it's Mind Bang. Everyone knows that.
I'm here with Emily on our favourite show, Mind Bang. Because
Does not resemble brain pop in any way.
Okay, so we are going to work out, well, she is going to work out, because she's the brains here. She is going to work out question 4 of the exam. And it's right over here.
The first question is, a woman pushes a child in a buggy up a ramp as shown below. The woman pushes the buggy up the ramp with a force of 100 newtons. Calculate the work done to push the buggy and child up the ramp. So, I know that work equals force times distance, and in the question it says that force equals 100 newtons. So work equals 100 newtons times, now to work out the distance we go 6 times 1, which is 6. So 100 newtons times 6.
Because it's going up a ramp.
Yeah. So that means work equals 600 joules. Work is measured in joules. So the answer...
No.
So A is 600 joules.
Good work, team. Now we're going to do question 4B.
So question 4B is, the energy gained by the buggy and child, mass equals 55 kilograms, at the top of the ramp does not equal the work done. Explain why these two values are not equal. In your answer you should name the type of energy the buggy has when it reaches the top of the ramp, calculate the difference between the work done and the energy at the top of the ramp, explain where the missing energy has gone and why this occurs. So, the energy that the buggy has at the top is gravitational potential energy because it's above the surface.
It has the potential to fall.
Yeah, it has the potential to fall. So, the type of energy the buggy has...
Possesses. Because he's possessed.
No, I'm going to write has.
Oh.
Is gravitational... Oops. Potential energy.
Right, faster.
It's hard, okay? This is because it has the potential to fall. So, the difference between the work done, so we know that the work done is 600. So, work done equals 600 joules.
Because we worked that out before.
In question A. Oh, question B, there we go. So now we need to work out...
Hold on.
We know that the work done is 600 joules, so now we need to work out the gravitational potential energy so that we can show that they're not equal, because it says calculate the difference between the work done and the energy at the top of the ramp. So EP equals mass times gravity times height. So we know that the mass is 55 kilograms because it says in the question, and we know that gravity is 10 and height is 1. So that means 55 times 1 is 55 times 10, so it's 550 joules. So you can tell by looking at the work done and the EP that it's different. So to explain this, more energy is used to get up the ramp as some of the energy is being converted into heat and sound
Due to friction?
Yes, due to friction. Between the wheels and the ramp.
Go round and round.
Or the buggy's moving parts. This is an excellent answer. So
Wow, Emily, you are getting excellence for this question.
Thanks.
So due to Emily's spaz, because the answer to the question is too long, We're just going to show you the answer and explain it.
Okay. So,
And we have some really classy music in the background.
yeah, okay. So, I don't know how to explain it. I'm just going to read it out and then explain it. Yeah. Okay. As the height above the ground is always the same amount of work is required to travel up the ramp as lifting the buggy straight up. As work equals force times distance, if d is increased, the amount of force required to do the same amount of work will be less, making it easier to push up the ramp. In other words, a long ramp allows the same amount of work to be done with a smaller force over a greater distance. This can be shown by the calculation, e.g. to lift straight up, force has to be greater than weight of the buggy, which is force times 55 times 10 equals 550 newtons, whereas the force used to push it up the ramp was only 100 newtons. So basically what they're saying is it's easier to push it up the ramp because it's a larger distance and you don't have to use as much work to push it up the ramp. And if you lift it up to the top of the ramp, it uses more work because you actually have to lift up the buggy rather than push it, which uses less force. And so they explain that in a technical way. Yeah.
Okay.
Thank you for watching Mind Bang, and this is your camera person.
Bye.
Bye.